Welcome everybody. Today we're going to be doing our first in a series of lectures on data science. And so data science is a burgeoning field. It's a hot field. It's a hotness that basically is a combination of programming and statistics, maybe mixed in with some other stuff. But basically those are the two big components of data science. And so if you've ever had like a giant like a Excel spreadsheet or something like that, and you ran like an averaging or something like that, that's like kind of a basic data science thing. So what I've done is I've downloaded all of the student data for this class. This is literally all of the activity for every student on this class. And if I scroll up here, you'll see here that the first row of this file, this is something called a CSV, comma, separated value. CSV, I'll type that in chat. CSV file. It stands for a comma separated values file. It's a very standard data exchange format. Some other common exchange formats would be like XML, JSON, various other markup languages as well. But CSV is pretty easy, and it's at a CSI 40 level of programming skill to parse. Now, all of you guys have done the Zybooks on string streams, and so probably some of this will be review for you, but based on the performance of the 12 o'clock class, maybe it's new for you. We'll find out. So the CSV file format is fairly easy to understand. You have what are called column headers, and so if you were to load this in Excel, this would be the very first row. Now, this is a really big file, so this whole thing here is actually the first row. It's just so long that it's wrapping around. And so what you see is this is the name of the column. So the first column is your student ID. The second column is your section ID. The third column is your section name. The fourth column is your course ID, so on and so forth. Now, this being Excel that I exported it from, it mangled the section ID into a floating point number because Excel is terrible and just doesn't know when to leave well enough alone. This also got exported as a floating point number somehow. It's just stupid and terrible. This is the first student's student ID number, except it's not, because I actually I wrote a program to change the student IDs. And so this is not actually a real student ID, so I'm not doxing anyone right now. The rest of the data, though, is all accurate. I removed all personally identifiable information from it. So this is one row of data. This whole thing, it's on two rows, but it's just, again, extending off the edge of the screen. If I shrank the font down, you'll see what it actually looks like. Let's see here. Put this on like 8-point font or something like that. There you go. So there is... now these are all student 714, again, not the real student ID. And so you can see that there's one row for each activity the student has done in this class this semester. So this is a complete printout of all of the activity that every student in this class has done. And so, like, this person's taken C loops take 2. They've looked at the grades. They've taken quizzes. They've done this. They've taken that quiz. So there's a lot of different activities they've done. And the main thing that we're interested in here is the times viewed and the times participated. So times viewed, they viewed this twice. They participated 0 times. They viewed it, let's see, course grades. I don't think you can participate in course grades, but they viewed their grades. They went home twice. They took the, they didn't take the comps exam there. They didn't take it here. Okay. This is like a complete record of like all of your visits to Canvas per student. And so let's say that we are data scientists. Data scientists will take a giant data set like this and we'll mine it. It looks like somebody was working on Zeta, maybe? Did I see Zeta on there? Yeah. All right, so somebody was working on the current homework assignment, and so on and so forth. So let me zoom back in because it might be a little hard to see. point font again. Anyhow, so here's one row of data, okay? And as you can see, each column is separated by a comma, okay? That's why it's called a comma-separated value format. So everything in this file is separated by commas. And so this is for student ID 714945, SIS ID, whatever mangled value that is, course ID, section ID. And so this column right here tells us, is the student in person or is it online? So a data science person will take a data set like this and analyze the data in different ways and draw like different interesting conclusions from it. Like, for example, are online students as engaged in the class as in-person students are? That's a valid question, right? I mean, since the pandemic, we've permanently left, half of our first year classes as online as the result of the pandemic. There was a lot of demand for online. You guys are online right now. And we want to know, like, is online as effective at making contact and having students participate as in person? And so this is the kind of thing a data science person would do. Look at all this thing and draw conclusions from it. That's what data science is. You take a giant chunk of data and you figure out the human story behind it. You figure out what's going on. And there's websites, which we'll talk probably more about next time, that just have data sets on all sorts of things, and then you can mine them for data and find out all sorts of interesting things from them. So the question for us right now as computer science majors is, how do we get all of this data into a data structure that we can work with? Okay, so the first thing that I think would be maybe leading up to what's going to be your analysis part later on would be, how can we change? How did Professor Kearney change these student IDs into fake ones? Okay. So how could we go about opening up this file and just changing the data before the first comma into something that isn't actually their real student ID? Let's work on this together. So I hope everybody is online, and we're going to code this part up together. Okay. So get line with a comma delimiter is exactly that is the clutch move you need to make, is get line with or actually I use read line because read line is just superior. You read from a file with the comma delimiter, and that gives you all of the data before the first comma. Okay. We're jumping ahead of the game, so main.cc to old main.cc, then main.cc. So let's just do this cooperatively. So everybody who's here, give me a thumbs up on chat. 14 people on the stream right now out of the 40 in the class. Fantastic. Okay, so Hernandez, how do I open a file? What is the thing we need to? What line of code do I need to open that file? The name of the file was student data. That's the name of the file. Hernandez, how do I open this file so I can read from it? I'm going to read in all that data, and I'm just going to change the student ID to something not personally identifiable, right? Because this is all being displayed on YouTube, and we don't want to have any PII up on the interwebs. Very good, very good. You got it exactly right. So ifstream ends. Does it have to be called ends? No, but yes, it's convention for me at least. Some people call it like in file or something like that. I always use ends. Okay, that's just my habit. Okay, so how do we check to see if everybody just type it out? How do we check to see if this file failed to open? That's a great question, right? Because it's possible, like, I deleted the file, I might have moved it. Every time you open a file, you really should check to see, like, if it kind of failed to open, right? Do we need to include fstream? No, because the read library includes it. But if you want to use If you don't want to use the read library, yeah, fstream is your friend there. So yes, if not ends is checking to see if there's an error opening it. And then we could just do something like cout error opening file. And then we will just die. Okay. Neat. Now, how do we, okay, well, do we know how many rows are in, do we know how big this file is? Do we know how many rows are in the file? We could probably check, but like just off the top of your head, do you guys know how many rows there were? No? Nah. So we should probably use a while loop, right? While ends is pretty common. While true works also. We've already checked to see if there's an error there. While true. Now, we're going to read one entire line at a time from the file. And so we can do it still like this, strings s is equal to read line ends. And so this is going to read the entire first line, first time through the loop. It'll give us the entire first line of the CSV file. I want to call it a CVS file, like pharmacy. But we're going to read this, and then we're just going to, yeah. Every time you read from a file, what should you do also? What is the thing you should do every time you read from a file? Because there will be an error. Every time you have a loop like this, there's going to be one very specific error you're going to get guaranteed. Yes, very good. If not ends break, exactly. And the reason for this is that you are basically guaranteed to hit the end of file at some point. If you've already read all the data in the file and you try reading again, that's an error. And then you detect it and you quit. So there's other errors we could have, and maybe we could have a more fine-grained error detection system, but it's good enough for me. So yeah, we do that. And then let's just cout the screen. And we'll just stop here and just make sure everything's working. Because who knows, maybe I misspelled the file. Okay, looks good. We've got down here 10.7.11.18 bim student data.csv. The last file is 10.7.11.18. All right, so the bottom of the file looks right. Let's look at the top of the file. We've got opportunities for the next month or something like that is the first line. So if we run our program and we pipe it through head shows us, in this case, the top 5 lines. And okay, there we go. Opportunities for the next month. Okay, so we're getting all the file. This thing here might cause us a problem in a little bit, but we'll just see what kind of problems we get with having the column headers in there. All right, let's come back over to here. And this is, by the way, how you should be coding, right? Write 5 or 6 lines of code, save it, compile it, test it, make sure it's all working. Don't assume that it works. Like if you had a, typo there, then you're gonna not be able to go any further, right? You gotta always be, making sure that your student code. You always have to be making sure your code is working at all times. I never leave my code in a state where it doesn't work. It's always in a place where it's working. It's not doing everything that I want, but right now it's just dumping the whole thing to, the screen, something. It runs, I never leave my code in a broken state. Okay, so now we need to grab the first column of every row, the student ID, basically. And so we're going to do this by using the power of string. So I'm going to make it input string. Input string. Yes. Input string. String turns a string into a stream. So you can read from the string as if it was a stream. Yeah. Now, why would we do this? Well, if we there's a really useful function which Olson talked about earlier, which is called getLine, also known as readLine if you use my read library. It's the same thing. And what it does is it reads normally until the end of a line. But there's an optional second parameter where you can read until a specific character is read. And we're going to read until a comma is read, because that's the first column of data there. And so what we're going to do is say string s2 is equal to, or we call it column 1 is equal to read line, and I'm not reading from the file anymore. I'm reading from the International Space Station. Sorry, the input string stream. So basically, this string here holds that entire first row of data. And what I'm going to do now is treat that as if that was its own file. And I'm going to read from that until the first comma is read. And that's going to give me the, that's going to give me the student ID of every person. And so if I can do this a couple times, this. If I do any more, I'd probably want to put it into a vector of strings, right? I'll just do these three. See out, call 1, the tab, call 2, the tab, call 3 with an inline. And let's see what we get. This should give us just the first 3 columns of data. Cool. All right. So if I vim student data.csv at the very bottom, you can see the student ID is correct, and these things all look correct. And if I go up to the top, or I can do it cat student data.csv, pipe through head -n5, pipe through cut field 1 through 3, delimited by commas. This is how I do it in Unix, by the way. The more Unix you know, the better off your life will be. And so instead of writing that whole program, I could just do it using Unix shell scripting, because Unix shell scripting is amazing and allows you to do things very quickly, very fast, and get quick answers real fast. So here is the first 3 columns. That's what I'm telling it right there. Give me the first 3 columns of data from a file that is delimited by commas, which a CSV file is. And so it's giving me the column headers here, and I piped through head -n5. N5 says give me the first 5 lines. So I've selected the first 5 rows and cut out just the first 3 columns, and there is the upper left corner of my Excel spreadsheet, essentially. And then I can run the program and pipe the result of that through head -n5 as well. And rather than flooding the screen with all this data, I can just kind of look at it and be like, yep, that is correct. Always be testing and verifying your code. And I can do the same for the bottom and stuff like that too. Okay. So rather than wasting more time on that, we are good. All right, I actually don't need you anymore. I'm just going to get the rest. So I'm going to get the first column, and then I'm going to get all the rest of the line. So I'm splitting. I'm essentially splitting the row into the student ID and the rest of the line, because all the rest of the line is just going to be unchanged. Because remember, what I'm doing here is I'm going to switch out the student IDs with random ones so that I'm not compromising student, personal identification information on the internet. So, okay, so we got that. Okay, now we need to do the magic. We need to substitute out one student ID for another one. Okay, so how can I do that? Remember, all of the same student numbers have to map so like if I change this guy to like 1,000, right? This guy needs to change to 1,000 as well, because it's the same student ID. So all of the same student ID has to change to the same number. Okay? So how can I do that? How can I map from one number to another? Or map from one string to another? Or map from a string to an integer? What is the data structure that allows us to map from one thing to another thing? What data structure do I need here? I'm going to need to write it down, right? Every time I see a student ID, I need to remember that I've changed 714,945 into 4,023. So every time I see 714,945, it changes into 4,023, right? I need to store that in a map of some sort. What sort of map should I save it in? Yes, that is correct, a hash map. That is exactly right. So I'm going to need a hash map, which is called an unordered. Let's go here. That's called unordered map. And we're going to have an unordered map here that's going to map between. We can do a string and an integer. We can do an integer and integer. And string's probably easier. String and integer. But I can get a cool crashing bug if I do integer to integer. So we'll do that one. So we'll get this guy hashimaku. Okay. And so what it's going to have, the key is going to be their original student ID, and the value is going to be their new fake student ID. Yep. Hash brown, exactly. So the key is going to be their original student ID, and the value is going to be their new fake ID. Okay. And so, first of all, I'm going to need to be able to convert this into an integer. What is the name of the function? Integer current ID is equal to, what is the name of the function that converts from a string to an integer? Anyone know? Stoy? Sure, why not? I think there's also from chars, which is arguably better. I think it's actually quite a bit faster. Whatever, stoy it is. Okay, so we're going to stoy column 1, and we're going to save the result into current ID. Okay, so stoy stands for string to integer, and it will convert a string into an integer if it can. If it can't, it will crash your program. So just be ready for that. Okay, so now instead of outputting the string column 1, we're going to output current ID followed by a comma, followed by the rest, followed by a new line. So this should now give us something that looks exactly like the original file, except we're crashing. So where in my CSV file is the first column not a number? So where inside of this file is the first column not a number, not a valid number? Yeah, the very first row. Exactly. You guys got it. Right there. We're crashing right off the bat because we're reading the first column in. The first column contains student SAS ID. We try converting student SAS ID into an integer, and it's like, throw an exception, program quits. Okay, so yeah, your very first hash brown causes you to crash. So what we actually should probably do is just throw away the first line, or just print it to the screen or something. So we can do like string s is equal to read line from ends and cout s. There, and then just print out the column header row. And there we go. So now we are getting essentially the original file back. Like this is the original thing, except that first thing there is held in an integer now. And so now we're ready to go. All we need to do is swap out the current ID with whatever fake number we come up with for it. Okay. So, all right. So the first thing we need to do is say, well, how do we tell if we have seen this ID before? Shin, what is the command, what is the function called that tells us if the hashmapu contains student ID? So I want to say if hashmapu, yes, count is correct. I would also accept contains. contains is C++20. Your LSP is in C++17. So your version will get mad at you for using contains. I prefer it to count, but I'll just use count so you can copy my code without having the thing underline and be mad at you. So if hashmap.count current ID. Okay. So if we have already seen this thing, do nothing. Otherwise, we'll probably take that out or make this a not, but it's funny. Otherwise, now we're going to need to make a fake ID. So how should we make a fake ID 6 digits long for the student? The student's current ID is 420, 420, and we want to randomly generate a 6-digit long ID for them. How should we do this? So all the student IDs right now are 6, some are 7. So what should we do? Rand, okay. So we'll say hash map to square bracket current ID will map to rand. Like that. New random, let's try it actually, let's see what happens. And so instead of outputting the current ID, what we're gonna do is we're gonna output what hash map maps to. And there we go. So this guy all has the same random ID here. We scroll up, we got the same random ID here. So the first time we've ever seen this ID, we generate a new random ID for them and then use that instead of the original correct one, right? And if we've already seen it before, well, we don't have to do anything. So I could probably delete this or make it a little cleaner. Okay. Make sure that zeros are added to make it 6 digits if it's less. Ooh, interesting. Or we can just like add 100,000 to it or something, maybe. So we could like rand modulus 900,000 plus 100,000. Something like that. And now we've got, there we go, 498, 315, 894, 324, 998, 537. Good. There is a small chance that 2 students are going to be randomly given the same random ID. So I don't know. There's no easy way to check if that one has been. Because you can search a hash map for the key, you can't search it for the value. So we will need an unordered set maybe of integers called randos. And we'll just make sure that, just as a little safety precaution, we will just make sure that none of these have been made before. So. So if randos dot contains value, so if we've seen it before, then try again, and then we will be good. Randos dot insert. Okay, so what's happening here is we're gonna keep rolling random dice, and probably we don't need to do this. Probably it's not even gonna come up. But just in case it does, in fact, I'm actually curious if it does. Let's see if we got the same random number twice. And then we'll just die. All right. No, there were no duplicates. All of this effort was wasted, but makes me happy to know that we're handling it properly. So set and map are they different from unordered set and unordered map? Yes and no. They effectively work the same way. If I changed unordered map and unordered set to map and set, you would see no difference in the output of the code. These, however, are faster. So map and set run in login time. So if you have 1 million rows here, 1 million students, it would take 20 steps for a map or a set. It would take 1 set for an unordered map or a set. So it's, in this case, 20 times faster. But the actual functionality, you're not going to notice any difference, except if you're printing them out. An ordered set always is alphabetized, so to speak. It's always held in sorted order. So if you see out it, you're always going to get the numbers in a nice order. I'm not ever printing either of these things, so I don't care. So I want the speed. But yeah, if I change this to map and set, you wouldn't see the slightest difference. Okay. Only if you're like running timings and starting a stopwatch, you'd be like, oh look, it's 5 milliseconds faster. Okay, so what I did here was I would generate a new random value. Then I checked to see if I had seen that random value before. If I had, I would continue. Continue comes up here, and it rolls again. And it'll just sit there and roll numbers over and over again until it finds one that hasn't been picked before. Hopefully, we do not have more than 1 million students in here. If so, you will be waiting a very long time. There's only 900,000 possible, students. And so if you start getting close to 900,000, that thing's going to be rolling the dice a long time trying to find the last random one. And so we probably need to revisit this algorithm if we get more than 900,000 students. But if we've seen it before, we re-roll. For small numbers of students, this is not going to be an issue. There's like 80 students in this class. This is fine. And then we add to the hash map, we add the new fake ID, which bad. There. We need to add the value that we just rolled there to the hash map, and then we need to write down that we have seen that random value before. And then we're done. That's it. Oh. And now we've got all sorts of nice fake 6-digit numbers, and all of this will be saved into student records.csv, and we will copy student records into /public. And now I would like for you guys copy main.cc into public CSV parser kind of .cc. So what I'd like for you guys to do is copy /public CSV parser kind of to your current directory, copy /public student records.csv to your current directory, and then do the following. I want you to open the file, and I want you to read all of the data in it into a 2-dimensional vector. Basically, every row, every column, intersection, right, is one string. And so every row is a vector of strings, and then you're going to make all the rows. And so you're going to have one vector of strings for every row. For every column within the vector of strings, there's one string corresponding to it. So basically, you're loading an Excel spreadsheet, right? If you look at student records here, then this is basically a 2-dimensional grid of text data with student ID. So this would be row 0, row 1, row 2. And so you can have like row 2, column 3, like that. And you can access any row, any column to do your data science analysis. So you are going to, our topic for like the next 2 weeks is going to be this kind of stuff. I don't know if it's going to be the full 2 weeks, but your data science homework is due next Friday. So yeah, more or less, this is going to be our big topic for the next 2 weeks. So learning how to read a .csv file, how to parse it, how to split it by column, the big cat. What we're going to do hint read line ISS comma will read from the iString stream until the next comma and return the string before. So this is the key, because a comma separated values file has commas separating each column. And so in order to get the text in each column, you're going to repeatedly call read line or get line if you want to use the standard library, passing in comma as the second parameter. And then that will allow you to split this big row of data with comma, 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 comma. You can split it into a vector of strings. And basically just read one column, push it into the vector of strings, read a column, push it into the vector of strings over and over again. And then after you've hit the end of the row, you've got a vector of strings, and you push that vector of strings into the vector of strings. And at the end of the day, you're going to have a nice two-dimensional data set with which you can run your first analysis. And your first analysis is going to be answering the question, which section, the in-person or the online section, is more active? I think the course that ends in section 80 that ends in 31 is the online section. The section that ends in 39 is the in-person section. So compare the two sections and see which one is more active. And so it's 3:13 right now. You guys got until 4:13. I'm going to give you an hour to work on this, and then I'm going to come online and solve it. Okay? So I'd like for you guys to all start streaming your screens, and I will watch what you're doing. As a hint, you probably don't need a hash map for this, so all that code involving hash map is just there to come up with fake IDs. We're not doing that right now. We're doing a different thing, so you don't need the hash maps right now. Probably. Maybe. Okay, so all of you guys, please start streaming on your screens, and I'm going to watch you guys for the next hour as you work on this. This is good practice for you. Yep. Pausing the recording now. And we're back. So we're going to open the student records. We're going to read everything into a vector of vectors. And looks like that kind of stymied some people. So let's see if we can do this. We're going to be reading from student records this time. That's the one with the student IDs that have been changed twice now. All right, so we're going to read a line and throw it away, because again, we don't want to mess with the header information, right? So we don't need these unordered maps right now. I need them later. We're going to make a vector of strings in vec. We're going to read a line at a time, and we're going to split this. We're going to split this line. So one line is going to be something like student ID, comma, section ID, comma, this, comma, that, comma, that. So every time we read a line, it's going to be a giant long string filled with commas in between. We need to split this into individual strings. Now, strings are perfect for this. And we want to do something like this over and over again in a loop. So we want to say while true, and we're going to basically do this thing here over and over again in a loop. Call this string skirt. And every time we read from the string, if there's no data left, we try reading from it, we get an error. So then we simply say if not ISS break that. And then if it is valid, then we are going to add it to a vector of strings named line. So this vector of strings is going to have all of the columns, each in its own entry in the vector. So we're going to say line.pushback, and that is going to construct. So if there's 20 columns, then line is going to have 20 elements at it by the end of the line. And then we are going to add this whole thing to vec. So we're going to add one line at a time to our vector of vectors, and we're basically done at that point. So this is going to create a 2D array of all of our data. So if you want to look at the data again, student records is this giant. Every row has, I don't know, 20 columns or something. I didn't count on it. And like that's one entry. So, you know, entry, what is that? Vector. So line.at0 will hold the string 789383 in it. Line.at1 will hold that string. Line.at2 will hold that string. Line.at3 will hold that string, so on and so forth. And so this string matters because we're trying to do data analysis, right? We're trying to figure out if the online session or the in-person session is more active in class. And so we need this one. So this is going to be the second column here. But before we do this, before we actually get to our analysis, let's just try printing out this vector of vectors. And while ISS will not work because it'll appear to work, but what's going to happen is that the last element, you're going to read it. It's still valid. Maybe it's not. Oh, whatever. You might get a duplicate entry in the last one. Basically, every time you do a read, you're going to want to check for hitting the end. I think readline might actually invalidate it because it reads until a comma. There's no comma. It might actually work if you do while ISS. Sure. I always check though. Every time I do a read, I always immediately check afterwards if there was an error. So I never do a pushback with invalid data in it. It's just a habit that I've learned. Okay, so how do we print a 2D vector? Okay, so we got this 2D vector here, a vector of vector strings. And so what we can do is we can say for every vector of strings named line inside of the vector, let's call it row maybe. So for every row in the vector, make this constant. For every row in the vector, for every string, called column, for every column in that row, we will see out the column with a tab character between it. And at the end of the row, we will see out an end line. It needs to be constant also. Okay. So there's all of our data with tabs between them all. So we can verify at 1118 down at the bottom. We are in fact getting all of the data. Everything's been read into a giant 2D array of strings. Each one of these things here is a string. It looks like a number, but it's actually a string. And so all of these things have been properly read into this giant 2D matrix. And now what we need to do is do our analysis on it. Okay. So I guess we can probably just comment this part out here. And then, so what are we going to do? What are we doing? Actually, as long as we got that loop there, not print out everything, right? So what we can do is we can say, for every row. So for each row, for every entry, if row.at2 double equals that is the online section, I believe. So if the second, the third column, column index is 2, goes 0, 1, 2. The third one over, right? This is 0, this is 1, this is 2. So if that is the online section, then we will make some variables. Integer online view. Sure, why not? Because remember, there's a couple things that we're interested in. There's a number of times that the student viewed Canvas, and there's a number of times they participated on Canvas. And so we'll look at both of these and see if there's some interesting differences there. First viewed, last viewed we could look at, but I think these are mainly the ones. So that is column ID 0, 1, 2, 3, 4, 5, 6, 7 is times viewed, and 8 is times participated. So we need row.at. So this is the online section. And then if it's false, we're going to assume that is in person. Although if we wanted to be more safe, we could double check that the section ID matches this one here. Okay, so there's 4 numbers we care about. There is the online view count, the online participation count, and then there is the in-person 6S in-person view and dot, and there we go. Okay, so these are the 4 numbers we care about. Let's do a little data science. Let's add them all up. So if we are in the online section, then online view is going to have row.at7 added to it, because remember 7 is the count of the number of times they viewed that assignment. And the oh, that's a string, right? So we have to convert this to strings to integer it, and this will be participation, and that will be for column 8. So just as a note, column 2 holds the section ID, column 7 holds the times they viewed that activity, and column 8 holds the times they participated in that activity. Okay. So you got these two, y2y, and p, and 6s, in person, and a dot, and I think we are done. I'm reporting macro by accident. Okay, so cout in-person views is going to be in-person view in-person participation this is the kind of stuff I used to do for a living. Online view, online participation, 678, 8s, online view, and dot. And there you go. So you can see that the in-person people viewed Canvas a little bit more and participated a lot more than the online section. Now, this isn't, we're not done here, right? I could probably get rid of this. Okay. Because one thing we do need to do is actually, one thing we do need to do is count the number of unique people in the online and the in-person sections, and then divide it out. Because you know, if the enrollment numbers are different, then we need to account for that. So, but I think that's pretty good to stop for now. So in order to count unique IDs, we would need to use a hash map or an owner set, technically. But I think this is a pretty good stopping point for now. So this is kind of what you do when you do data science, right? You parse a file. If you're using Python, they have a CSV open thing for you, and it's in pandas that just does that for you. But I think this is a pretty good exercise for you guys. This little method here using string streams, and all of you guys should have done the string stream zybooks already, right? Is you take a string and then you can split it using string streams, using getLine or readline, which is effectively the same thing. Okay, and then you can chunk it up into each column, and then you can add it to a vector, and then you can add that vector to a vector of vectors, and now you've got a 2D data structure that's got all of the data in the Excel spreadsheet in it, and then you can just access each row, each column, however you want, and do whatever sort of analysis you want. So maybe next time we'll work on a different CSV file and maybe average salaries or something like that. You're going to have a big homework assignment due on next Friday. We'll probably also talk a little bit about Zeta on Thursday if you guys are Wednesday. If you guys are having trouble with that, it should be a fairly straightforward assignment. It's not designed to be a deadly one. But if you have questions about Zeta, we can talk about that on Thursday. But basically, this is something I'm kind of excited about, getting you guys into actually doing real analysis on real data sets. You're going to be able to choose your own data set and run different analyses on it and see if you can find out interesting conclusions. So that is it for today, guys. Thanks for coming out. For the 7 people that stayed for actually doing the coding, I appreciate you guys. For the people that didn't show up, why are you not here? I understand some of you are working, and some of them I understand. That's always better to try and fail than to not try at all. You know what I mean? And I know some of you guys work and stuff like that, but there's like 40 people in this class, and there was only 8 people streaming. So I know it was tough. Absolutely. Thank you, girl. And with that, I'm gonna enjoy my kung fu pudding nacha. It should have been tough for everybody. So yeah, it's don't beat yourself up. What's important, the way that you learn is by struggling and trying and failing and then seeing what the answer is. If I just give you the answer, you don't learn. You have to try. You have to try and figure it out in your head and work it over. And so when people just like, I'll just watch the stream later, it doesn't stick the same way when you try it. So it's good for you to try and fail. It really is. It's called learning through failure. And that's why this isn't graded, right? Because I don't want to punish you guys for, trying, right? That seems counterproductive. So the goal is to get you thinking. It's the hardest thing. So that's it for today. I would have been there today in person, Brad back town. Yeah. There was a lot of people missing in the 12 o'clock session too, Burford. All right. That is it for today, guys. Thank you very much.